All right, today we're going to talk about what happens when concrete gets too hot. Say, for example, if we are cutting steel over top of a concrete floor and we get it too hot and it starts to pop or degenerate. Uh, how hot is too hot? What do we need to do to mitigate that? Now, Portland cement concrete can't withstand exposure to 1500 degrees Fahrenheit without undergoing severe strength loss and cracking because the hardened paste dehydrates at such high temperatures. Now, if concrete's made with high alumina cement and refractory aggregates, then it might be able to withstand such exposure conditions. But that's not the kind of concrete we're typically working with. We are typically working with Portland cement concrete. Now, up to about 932 degrees Fahrenheit, the concrete undergoes normal thermal expansion. Above 932 degrees Fahrenheit, above that temperature, shrinkage occurs due to water loss. However, the aggregate continues expanding, which causes internal stresses. Up to about 932 degrees Fahrenheit, the major structural changes are carbonatation and the coarsening of pores. So what happens if you heat concrete? Well, when the concrete's heated, the cement inside becomes dehydrated, losing some of its water as vapor. The water vapor begins moving away from the source of heat, but it becomes trapped inside the structure of the concrete. So when that starts to happen, because of the degeneration, the concrete can start to spall. It'll start to pop or degenerate and break, especially if, for example, you're cutting over top of concrete with, say, for example, a cutting torch. Then there's every likelihood, especially if you're not very far away from that concrete, that just the slag falling on there or the heat from the torch tip is going to cause the concrete to fundamentally change internally. And the effect of high heat temperature on concrete is such that the abrupt temperature changes can cause cracking and spalling due to this thermal shock and aggregate expansion, and can also produce distress within the concrete. So realize that when you're cutting over concrete, you're going to have to make some adjustments. One of the ways that you can dissipate the heat is by getting a piece of plate and sticking it underneath whatever it is you're cutting over top of the concrete area over which you're cutting with a torch. That will allow the steel to absorb the heat that you're throwing down, and it will not go directly onto the concrete and cause it to spall. That way you won't be getting this popping and degeneration of the concrete underneath. This is something that we encounter from time to time. It's good for us to consider it so that we can do our job safely. And so I want to address this issue with you today so that when you're cutting over concrete, you can do it safely and without causing the concrete to degenerate and perhaps cause an injury.